So after I decided that I wanted to build an arcade, literally the first thing I got was a set of joysticks and buttons off of Amazon. And these are really cool looking. They light up and stuff. And this was the inspiration for the whole arcade. And early on, I decided to go with a Raspberry Pi 3B. At the time, that's what was out. I wanted to keep it nice and simple instead of getting a PC and dealing with the Windows and all of that. The Raspberry Pi is really small. It's cheap. At the time, it was really cheap. And they run cool, and they're pretty easy to deal with, as I watched quite a few videos on YouTube at this point. So that's what I did, and this is what it looked like. I just made a mock-up where I put the buttons on just a piece of 3/4-inch MDF, and just basically made like an arcade controller, and the Raspberry Pi is just stuck underneath it. And we just hooked it up to the TV, and we had fun with this for quite a while. You can see how it's kind of wore out on the top of the MDF. But yeah, it existed like this for quite a while before I finally got around to doing a design for the arcade itself. All right, so I just wanted to show you guys where I initially started this project, where I basically modeled the arcade in Blender just to kind of see what it's going to look like and try some design ideas and color choices and that kind of thing. So this is the initial version, and I would later modify this, and I'll show you that in a second. All right, so here's an updated model of the arcade in Blender. I made a few changes to dimensions and the angle of the screen because I thought the screen was a little too vertical. So I laid the screen back a little bit. So that's what this currently looks like. So I kind of decided early on that I thought the arcade would look great black and red with, black sides and red T-molding. So that's what I went with. And I thought it'd be really cool if you put car wrap on the sides that was carbon fiber. I thought it was like breaking new ground there, but apparently a lot of people do that. So it was new for me. So at this point in the build, I had my 3/4-inch MDF. I had some 1/2-inch MDF. I bought my screen that I was going to use, and I had the Raspberry Pi already, and I was ready to go. But then the COVID pandemic hit.
COVID-19 lockdown.
So lucky for me, I had a few Amazon gift cards saved up, and I had some material to start working with. So I thought this would be a good time to do this project. So off I went. Early on, I decided that I was going to use my router with a pattern bit. And so the first thing I wanted to try to do was to make a pattern that I could use with the router for the sides of the arcade. And I wanted to do that at a 1/2-inch MDF because it's just a little easier to work with 1/2-inch MDF, and it's only going to be a pattern. So being a thinner material, it's a little easier to machine and work and sand and stuff like that. And I wanted to use a pattern so I can get both sides to be exactly the same, and it worked out really well. So this is kind of where we are on the build right now. This is the 1/2-inch pattern I made, and then I wound up just putting some nails in it and just to attach it to the 3/4-inch MDF. Because I didn't have two-sided tape at the time, I figured I would just do that and then just worry about the holes later on. I could just fill those. So I have a router table, and that's what I wound up using for this to make these cuts. But you can use a handheld router, which I do later on in this build. So far, so good. I mean, I wound up with two perfectly exactly matching sides. What could possibly go wrong? Foreshadowing. All right, so this is where we're doing the slot for the T-molding. And this is where I run into problems. The T-molding I have has kind of a wide tongue, and it's not very deep. This is, I use the right size router bit. It's a slot cutting bit. So I did it on my router table. After I did it, I realized that there was a problem. What happened was the MDF had a slight bow or cupping, so that is not great if you're going to use it on a router table because the bit will not follow the shape of the MDF, if there's a cup. So you wind up with this. You could see that the T-slot cut is drifting to one side. So I wound up not using these two sides because I didn't really know how to deal with this at this moment. You know, you could fill it in, I guess, but I actually deal with this later on. So I kind of put these pieces to the side. I'm like, I have enough MDF. I'll just cut 2 more side pieces and not screw it up this time. So that's what I did. And then I decided that using a handheld router is a much better option. So if you're doing this at home, do a handheld router because it will ride along the contour and the overall curve of the MDF if there is a bow or a cup in your MDF. Mine, it was a slight one. I didn't think it was that bad, but when you run it with a router table, it reveals how cupped it is. So don't do that. You can see here, this is the Marquee panel, and I got this idea from, there's a guy on YouTube, School of Shop, and he did a really cool thing for his marquee, and I thought it was a good idea. It's not really like based on a real arcade cabinet, but I think it looked really nice and it was very doable. And it was like kind of a good option to basically hold the plexiglass and the artwork by making like a frame out of 3/4 inch MDF. So that's what I did here. I have 3/4 inch MDF and I have, again with the nails, I nailed strips of pine to where I wanted to cut with the router. So I'm using the pattern bit again. So this is the router table and you could see the pattern bit. It has the bearing on top if it's upside down like this. And it's very nice and easy to do it this way, and it's pretty safe, I think. Just keep your fingers away from the cutter. But and what I did was I think I used a jigsaw to cut out the most of the middle on the 3/4 inch MDF, which is underneath in this shot. It's on the bottom. Yeah, so the pattern bit, the bearing, is going to ride along your, in my case, I have pine. Here, it's just going to ride right along that, and it's going to give you nice round edges in the corners because it's a round cutter. It can't make a square corner, obviously, but that's perfectly fine. So for this build, I really didn't do a big printout on paper and then use that as a, you know, as a guide and to transfer all the measurements and stuff like that because I don't think it really needed that. It's pretty straightforward. The whole idea when I was first creating the pattern was I left enough room because I wanted to do the technique where you put 3/4 inch by 3/4 inch strips of wood in all the corners. And it really makes it sturdy and nice and strong. And it's glued down. It's also pneumatic nailed with a nailer or nail gun. And if you notice that one piece there is a little thicker, that's where the control panel is going to rest. And I wanted to put screws in the edges of it to hold it down. And they're visible screws because I kind of like that look. So where you use a little metal washer or I don't know, it looks like it looks industrial. I think it looks pretty cool. So that's what I did. And you can see here on this is one of the actual sides. And I'm gluing up, you know, the interior supports along the edges. And you could see that there are lines drawn. And I think basically what I did was I just measured in how far I wanted to come in, you know, 3/4 of an inch plus a little extra, maybe another 1/8 of an inch. And then I would draw my lines along the edges. And I did that on both pieces, the left and the right side. You got to remember that it's mirrored. You know, you got to keep that in mind when you are gluing up and choosing your insides. So anyway, this is how far it is. I think it's coming out great so far. It's starting to look like something. This is kind of the fun part where you start to put pieces together. So now I have both sides kind of glued up, and I came up with this idea for my screen. I wanted to just use 1/2 inch MDF. I'm trying to use 1/2 inch MDF where I can because a little bit lighter. Okay, so at this point I have both halves done, and I have, you know, the 3/4 inch wood glued and nailed to the inside edges with the proper spacing so that when you put your 3/4 inch MDF up against it, you have clearance for that, and there's a little bit of extra space, I think an 1/8 of an inch. I just wanted to take a minute to talk about how to attach the screen. The way I came up with is probably not the way everybody does it, but the screen I have, it's a TV from Best Buy, and it's very lightweight. I couldn't believe how light this TV was, so I came up with this idea, you know, kind of an alternate way to attach it, and I'll show you that coming up. It's kind of cool. But anyway, so the screen panel that's going to hold the screen, I wanted to go with 1/2 inch MDF because it's lighter and you don't need anything too beefy for that. I'm trying to use 1/2 inch MDF where I can to save weight because MDF is so heavy. I wish they would come up with something else, but I think there's a lighter MDF, but I don't have that. So I went with 1/2 inch. So you could see here, I designed this basically an adjustable piece that it's not very clean looking or anything here, but it's just a piece of pine. And I put 3 screw holes that are slotted so it could be adjusted. And then what I'm going to do is, it's basically, I'm a big fan of sandwiching pieces together to hold them. So the panel will slide in from the back, and then these adjustable strips, there's one on each side, that will come in behind it, and then you can kind of tighten it down from the inside, and that will hold everything kind of together. And that makes a really nice tight fit. And it's also adjustable because I wasn't really sure. I have a piece of plexiglass, it's actually Lexan, that I've been holding on to probably for 25 years, just in case I needed it for a project. And there you go. So never throw anything out. All right, we're starting to put pieces together. It's starting to look like something. This is pretty exciting. And you could probably tell that in the middle there, I didn't put a piece of 3/4 inch MDF because I wanted to put a 1/2 inch piece there. So again, to save weight, and it wasn't really structural right there. And I wanted the 3/4 inch pieces in the front and back. You know, these are the ones on the bottom, because I wanted to put feet on the bottom of this. So I wanted to have something a little, substantial to hold the feet and hold the weight. And eventually I want to build like a kind of a box to put this up on top, like a base to it, but that's not something I'm worried about now, but I'm just trying to plan for the future. So here's some dimensions of this arcade. Your arcade is probably going to be different because it's kind of based on your screen size. I mean, that kind of determines the overall width and how everything is going to fit into your design. So you just want to build it big enough to hold everything, hold the screen. So my width wound up being 27.5 inches wide. This other image here shows the depth of where the control panel is. I think it's around 6.5. It's hard to tell from this angle, but it might be maybe 6 3/8. I don't remember what it came out to be exactly. So the depth of it wound up being 20 5/8 inches, because I didn't want to make it too deep. I wanted to keep it, it's a BARTOP arcade, so I didn't want it to be too big, just big enough to hold everything. And the overall height of it wound up being 31 inches. So here you can see I cut the control panel piece, and I'm liking how that looks. I also cut the screen panel piece, and I just kind of stuck it in there just to make sure it was going to fit properly, see what it looked like. So I think it's looking pretty cool so far. So this is the back door. It's a 1/2 inch MDF. I'm trying to save weight wherever I can, and it's just a door, so it's not really structural. I thought about this for a while, and I was kind of thinking about, should I put hinges, maybe a piano hinge, and then it just all seemed overly complicated. And also you have to have room behind the arcade if you want to swing a big door out, it's going to hit the wall or whatever. So I highly recommend doing it like this. Basically, I put 2 tabs on the bottom that you basically drop the bottom in, and those tabs will hold on to the inside of the bottom of the arcade. And then the top, I'm just going to use a real simple like door latch. Thought this was, a nice, easy solution. All right, so at this point, it's coming along. I got a lot of pieces put together. It looks like an arcade. I should mention that some of the pieces on here will be removable, like the control panel, the marquee frame, and the top piece. I decided to make that removable too. So these will have screws that you could just take out. And also, obviously, the back I could take out, and I'll show you that later on. So this image is my marquee image that I came up with in Photoshop. Eventually I will have this printed out onto vinyl that you can backlight, and it came out really cool. I'm really happy with the website that did it, and it's really affordable. I was really surprised at how cheap it was. So look for that coming up. Yeah, I'm really happy with how this came out with the print, and I'll put a link in the description of the company that printed it. This is how my arcade looked for quite a while, probably a year, I guess. I had the buttons and the joysticks already, and I had the Raspberry Pi, and I had a Retro Pi installed on it, and I had some games that I found. So me and my son were playing it like this for quite a while. You could see on top that it's kind of wore out. It's just MDF, without any paint on it, obviously. But it was fun. I mean, if you don't feel like or you can't make a full arcade, this is the next best thing. Just put some buttons and a joystick on a board and, just hook it all up. So it was a good learning experience to do this and see how it works and see if I like the button layout. And on the real arcade, I wound up having 8 buttons just because I had them and it looked cool and I wasn't sure exactly what games would need what buttons. So I figured I would just put all the buttons on, and you can see that later on. So this is the layout I eventually came up with. The circle on the left is the joystick hole, and the ones on the right are all the buttons. So I went up with 8 buttons, and I did them on a kind of an arc, which I think is comfortable that way because your hand is kind of at an angle when you play. And then the top 2 buttons are the select and start or whatever you want them to be. So those are actually smaller buttons that came in the kit. And I would have 2 sets of these. So I printed out these button layouts and I found it very difficult to try to get these to be centered on the control panel that was pleasing to the eye. I found that if I just tried to measure and center them, it looked wrong. And so do you split the control panel in half and then find the centers of those halves and then find the centers of your button layout and then center it that way? And it just didn't look right. So I kept moving these around until it looked right, because you don't want the left joystick to be too close to the left side and that kind of thing. So this is what I wound up. I think I taped it down at this point. This is what I wound up with, and I think it worked out. So this is the first look at what it looks like with the buttonholes drilled out. Yeah, I think it's pretty cool. I'm happy with how it came out. All right, so let me just explain what's happening here. This is the bottom side of the control panel, and the problem is 3/4 inch MDF is a little too thick for the joysticks. So what I wanted to do was router out a pocket where the joystick could be bolted from the bottom. And that will basically, if you router out like 1/4 inch, that will basically give you a little more length on the joysticks, like 1/4 inch more basically, because you're moving it up slightly. So that's what this is all about. I made this pattern here to use the router with a pattern bit, and it's a way to just cut out a rectangular shape and get rid of like 1/4 inch of material. On this tighter shot, I just wanted to show you that the actual thing I'm cutting is this, but all the rest of that is just the guide, which is kind of funny. So here's what it looks like with the pocket cut out, and the joystick base will fit into that. You can also see that on 2 of the holes at the top there, those are for the smaller diameter buttons. The shafts on them weren't as long, so I had to do kind of a similar thing, but I think I did this first. I used Forstner bits to cut all these holes, and I pre-cut the wider hole on those 2 top buttons to recess it in so you could put the nut. The buttons I have come with plastic nuts to hold them from the back. The thickness, the 3/4 inch thickness, was a little too thick for these smaller size buttons, so that's why I did that. So here I couldn't help myself. I wanted to throw some buttons in the control panel to see what it looks like. Did it like this with this layout, and the spacing between the buttons I think worked out well here. They're not too far apart, they're not too close. So yeah, everything's looking cool so far. So on this shot I did the other side, the other pocket for the joystick, and I have some buttons in there, and so far so good. Also I laid out the whole pattern for the joysticks, and I didn't want the screws to go through, obviously, so I think I just used the screws that came with the joystick kit, which are fairly short, so you're basically screwing it from the bottom up. Here's some more button glamour shots. All right, so if you noticed on my screen panel, there was a slot cut out in the bottom. This is a little bit out of order. So this is the first time I'm 3D printing something. And I figured that I would 3D print a small router guide so I can cut that slot. So this is the first pass on that. And I think I wound up not using that anyway. But I thought I'd include it because I'm showing the mistakes too. So yeah, my idea was to print this out and use it as a guide, and I would somehow attach this to the piece. I wasn't really sure exactly how I was going to do that at this point, but this is kind of like a let's just do it and see what happens kind of a situation. So the reason that I need this slot cut in the panel is because I wanted to have access to the remote control sensor, so I could still use that. So this would act as a little window, so when I turn my computer, I turn the system on, I still have control of the TV if I want to. So it'll just give me more options if I needed to change any of the input setting or anything like that. So I wanted to keep that intact. So my idea was to have this little window cut out to make that still something I could use. So I came up with this alternate design for this purpose, to cut this slot, and I gave it little screw holes and stuff so I could just kind of screw it to the piece from the back, because you would never see these screw holes from the front. But I just used short screws. I designed this piece and then printed it out, and it worked out really well. I'm really happy with how this came out. And what I did was I made it slightly bigger than the one I already cut, so I can just get rid of the mistake. That's one way to fix if you have a problem, just make a bigger hole and it will fix things. Okay, so here's the 3D print. It's screwed to the back of the screen panel, and it's all ready to be routed with a pattern bit. And then it's at this point where I realized doing these specific 3D printed patterns is really a value to building stuff like this. It kind of opens the door for all kinds of 3D printed pattern type situations. So the build from this point on, I kind of do that more and more. So yeah, I'm really happy with how this cut came out. It just came out perfect. And then when I'm done, I just unscrew the 2 screws, and then you're left with a really nice slot cut out. So here's the back door, and this is with the latch installed. I had to put a spacer block just to make it so that it was on the same plane as the rest of the back of the arcade, so that everything lines up. It came out great. This is a good way to do a door. It's like you just undo the latch, and then you can pull the door out and then just pull it straight up, and it will just come right off and in one piece. No hinges or anything. Yeah, I highly recommend doing a back door this way. So this is a shot of the screen panel. I just wanted to make sure that everything lined up correctly, and I cut the hole so that it's just as big as the screen itself. So the frame or the bezel around the screen is kind of hidden behind this panel. So that's what I wound up doing on that. And here you could see the remote input on the front of the TV and how it kind of lines up to the slot in the panel. And that allows me to still use my remote control. You could see here that I cut the Lexan for the control board and also the marquee. And eventually I'm going to have a piece that will go over the screen panel to just cover everything up. Keep dust out, and so people don't touch the screen, so there's like a little bit of protection like a real arcade. So that's where we are so far. And I used a Forstner bit to drill the holes in the Lexan, and that actually worked out well. Didn't crack it or anything. So this is what I was talking about earlier. This is my TV, and these are I designed and printed these brackets that will basically grab the edge of the TV and hold it down to the screen panel. And this worked out really, really well. I posted this on some Facebook groups for arcade building, and everyone was like, oh, that's gonna fail, and the TV is way too heavy, and it's all gonna fall apart. But no, I mean, these things are really, really strong. You could probably drive a car over them. There's a lot of infill. They're really, really sturdy, and this TV is so light. It's unbelievable how light it is. So I built this arcade a while ago already, and nothing bad happened. So it's perfectly fine. And it's actually a really good way to do that. Instead of using, was it the Versa mount? You could see the 4 holes on the back of the TV. You didn't really have to do all that. This is a much simpler way to do it. Yeah, I highly recommend doing it this way if you have a light TV or a light monitor like I have here. But if you have something heavy, I don't know if this is the best way to do that. So there you go. So this is the 3D model in Blender of the screen mounts, I guess I'll call them. And if you see these, if you notice, there's 5 kind of weird looking shapes at the, at the back of it. And that's because I basically modeled in my own supports, and these will be easily just broken off after the print's done. And the problem, if you're not familiar with 3D printing, is you can't print in thin air. It needs something to hold up. So if you have an overhang like this is a good situation to use support. So I like to just model my own. You can have supports auto-generated in your 3D slicing software, but I wound up just doing it manually because it was just quick and easy to do. And I didn't need anything too crazy support-wise. And I think I just put a really slight gap between the top of the support and the overhang. I think it's like a 0.5 millimeter or something. So I think it was enough to be able to just break it off. I mean, no one's ever going to see these, so it doesn't really matter, but as long as it works and holds that overhang up, that's all it really needs to do. So here's all the supports in place, and the bottom of the TV really didn't have a lip to hang on to, but I figured I would just put the same kind of bracket on the bottom too. It's really just kind of supporting the weight of it. It's not really holding it to the panel. You can also see at the bottom of the TV there's a little bump out, and that's that input window for the remote. In this tight shot you could see that I modeled slots in this piece as well, so they're fully adjustable, so you can kind of tighten them up. And it also gives you a way to center the screen in the hole. If you just loosen these up, move the screen around, and just slide them all in and tighten them down, so you get like a perfect fit. And this worked out really well. I'm really happy with this. Okay, so here what I'm doing is I'm testing a light that I got from Home Depot. It is an LED light that is meant to be hung underneath like a cabinet in your kitchen. I think it's pretty good. It has a lot of light. I think it's enough to light up the Marquee artwork. So here you can see I made these little special angled cut pieces that will basically act as a stop for the screen panel. So the screen panel would slide in and then rest on these little blocks, because I thought that I needed these in there, and I didn't really think about it before this. So that's what I did. I cut these out and I just clamped them in there and glued them. Here's a good view from behind with the door open. You could see how everything is kind of like coming together, and the panel is in place and everything is kind of tightened down and held together, and so far so good. Everything's working out. So back to the control panel. This is the bottom of the control panel. And I realized that I really need to cut more recessed cuts to allow me to put the nuts on the bottoms of all the buttons. Because the way it was before, it's still, 3/4 inch MDF is a little on the thick side for buttons. So I went up cutting pockets in all the buttonholes. And so this is me doing that. And the problem with using a Forstner bit is you kind of need the material to be there, or else you don't have any way to set your point of your Forstner bit if there's just a gaping hole. So you will never be able to hold it still enough unless you use a drill press to cut out what you need. So what I did was I took a scrap piece of MDF and I used the same size Forstner bit, and I just cut a hole clean through it, and then I would use that as a guide. And so what I did was I just used some clamps to hold the piece down over the hole that I wanted to make a little deeper, if that makes sense. You could see it on the other ones that I already did. So this worked out really well. You just basically put the Forstner bit right in your guide hole, and then just go down a little ways. And I think I wound up doing it till the top of the bit was flush with the guide piece, if that makes sense. More holes. This is the inside of the arcade in the back, and I wanted to add a switch, basically, as the main power switch. And then I also wanted to add another switch that I wound up not using for the LED Marquee Light, because I wasn't really sure how all that was going to be hooked up. But I drilled the hole, but I wound up not using it anyway. The rectangular hole next to that is for the fuse and where you plug in your power cord. So I'll show you that coming up. There's like a certain one that everybody uses for this kind of situation, and so that's what that's for. More 3D printed stuff. This is a template I made for the back door. I wanted to put 2 fans in the back. I know the Raspberry Pi runs kind of cool. It's not like a hot PC back there, but I wasn't really sure about the monitor or the TV I'm using and how hot that gets. So I figured it couldn't hurt to throw 2 USB fans in the back door. My plan is to have one facing in and one facing out. So I made this 3D printed template for the fan, and the cool thing is that the 4 holes there that you see, they line up to the holes for the fans and how the fans attach. So it's kind of a dual purpose thing. The way you attach the 3D router pattern is also how you're going to attach the fans and the fan covers. So it's kind of neat because once you cut out the main hole for the speaker through the back door, you already have your hole placement to hold the fans in. Okay, so here it's screwed to the door and it's all lined up. I did a bunch of measurements to get these centered. I like to hog out the middle with a Forstner bit just to remove as much material as I can, and man, this gets messy. But once I did that, it's a lot easier to run the router. So once you hog out most of the material, it's just easier for the router to give you a nice clean cut. So on these couple shots, you can see that I flipped the piece over. The router guide is actually on the bottom of the piece now, and that's the side that the pattern bit has the bearing that goes along the guide. So the bearing's on the end of the bit. So that way you do it from the back basically with the handheld router in this case, but you could easily also do this with the router table. Yeah, so the holes that you get are just so nice and clean, so perfectly circular. I posted this too on a Facebook group or two way back. Some of the people were leaving comments like, "Why don't you just use a hole saw?" I think hole saws are the tool of the devil. No, I'm kidding. Yeah, I don't know. I don't have a great set of hole saw blades. And the chances of having the exact size that you need is kind of slim. So the cool thing about making your own 3D printed patterns is you can make them any size you want. And it's cool, you could reuse them and stuff, and they just work really great. So I'm a big fan of using this technique for this. But feel free to use your hole saw if you want. I mean, I tried, actually in this video later on, I think I try using one just to test to see, and it's probably not the best hole saw. I think it might have been semi-dull, and it wound up just burning the hole a lot, and I was like, yeah, and then the piece gets stuck inside the hole saw, and you have to pry it out and stuff. So I don't know, it's just a mess for me. So I wound up doing all the holes this way. So I have a few more holes that I do coming up with more 3D printing. All right, you can see here we have 2 holes cut and they look great, and we're moving on. Here you can see I mounted the fuse, I guess you would call it a fuse box. Anyway, it's where the power cord gets plugged in, and there's a fuse in there. And then on the other side of that, there's a bunch of prongs that all get hooked up with wires, and that will basically be the electrical base to your arcade cabinet. Here you can see one of the fan covers and how the holes line up to the actual holes for the fan cover and the fan itself. Again, I should say that these fans are great. They're really quiet, and they run off a USB power. So I think I wound up just using a phone charger and sticking it inside the arcade into one of the power strips and just running it right from that, and it worked perfectly fine for that. Here you can see both fans, and I just turned one the other way around, so one would blow in and one would blow out. So you would kind of theoretically suck in cooler air and then blow out the hot air. So that's kind of my thinking on this. Here you can see I started to paint some of the parts. I put some primer on there. So far so good. It's looking pretty cool. It needs a lot of sanding and a little bit of filler, I guess. So far so good. This is starting to come together. All right, more 3D printing time. This is a little design I came up with for basically for holding this LED light that I bought, the one I mentioned earlier. And I realized that to get the most light evenly out of it is if you held it at a 45-degree angle. And so that's what this part is for. It basically allows me to mount the clips that came with the light. You're supposed to mount the clips to the underside of your cabinet, and then the light clicks into it. So that's kind of what how it's designed. So what I did was I came up with this design, which basically will hold the clips at the right height and at a 45-degree angle, and then the light would just basically go into these clips. So that was the thinking here. So here's what it looks like with the light attached to the clips and the angle that it's being held at. Yeah, so I think it's going to work out. More foreshadowing. You can see the top panel in place, and this is after I did all kinds of experimenting with different kinds of paints and stuff. This is what took most of the time on this build, was coming up with the black paint. And I will tell you in a little while what I wound up with and what worked great, because a lot of these paints didn't pass the fingernail test. If you paint something and then let it dry for whatever amount of time, a few days or whatever, a week, and if you could scratch it with your fingernail, then that didn't really pass for me. So I wound up with this black enamel paint. It's a spray paint, and it just, the finish on it is so nice. And it's one of those things where you paint it and it looks awful for the first couple coats, and you're like, this is never gonna work. And then if you just keep going over it with light coats, and then eventually you get to a point where you build it up, and you kind of sand lightly between coats to knock that kind of roughness down. And you just kind of have to keep going, because this is like 4 or 5 layers of it, and it just came out really nice. It's a little hard to see here, but it's a semi-gloss, and it just came out really nice. So this kind of inspired me to keep going with the paint, because I'm putting carbon fiber vinyl on a lot of the arcade. There are parts that are not going to have that. And so I wanted to have some way to do the rest of the black parts with, just by painting. And I didn't want to use a roller or anything like that. So I wound up just using spray cans. Here's a shot of the inside of the Marquee area. And I just wanted to show you what it looks like so far. This is with the brackets mounted and that hold the light up, and the light is in its position that it's going to be in, and it's far enough away so it illuminates the marquee fairly evenly. So far so good on this. So here we are outside. This is where I did a lot of the painting on my old deck in the back of the house. Yeah, so the railing makes a good place to hold all your parts. This deck will be ripped down at some point, but I wanted to keep it up long enough to do my painting on. So it worked out really well. I kind of had to paint on nice days, obviously, so that kind of limited. Again, this is where most of the time went on this build, was just doing the painting of these pieces. So you can see here how awful they look. I mean, this is after they've been primed and sanded, and now this is the black spray paint that I used on the top piece, and it came out really nice. So when you first do it, it just looks awful until you get a few coats and a few light sandings in between. So you have to just trust the process. Yeah, so the control panel really didn't need to have a nice paint job on it, because it's going to be covered with the vinyl. But I wanted to do the front and side edges just in case any of that shows. The front edge is actually going to have T-molding. So, and also I read somewhere that the vinyl sticks better to surfaces that are really smooth. So that's kind of what I was trying to do here. I think I put enough paint on there so I can kind of sand it and have it a nice smooth surface to work with the vinyl. So yeah, the same thing for this screen panel piece. It's going to be covered with vinyl. I actually got 2 different kinds of vinyl wrap. The one kind is carbon fiber, and the other kind is just this matte black, which I thought would be good to have on certain parts. So I wanted to put that on the screen panel piece. Really, the only thing that's going to show here is the cut edges, like the inside of this slot, and then the inside edges of the main hole for the screen. So that's what I'm doing here. And I think I wound up painting it nicely anyway, and then sanding it just so we have a nice smooth surface to put the vinyl on. So this is the back door, and this was made just with a scrap piece, because it's the back of the arcade, so you're not really going to see it. And it just had awful marks on it and some kind of tape or something, so it was not in the best shape, and I kept sanding it and painting it and sanding it. It was kind of a disaster, but it's the back of it, so I didn't really care too much. Eventually I do get it fairly decently smooth, or smooth enough. You can see here in this image I made just a quick sketch of the arcade, and this is just showing how much T-molding I would need for all the parts. Like if you just kind of went around the perimeter of the side, if you add all those numbers together, that's how much T-molding you would need for one side of your arcade. And then you have to figure you have other pieces that need T-molding, like the control panel and that kind of thing. So I wound up needing 19 feet, and I wound up getting like a 25-foot roll or a 30-foot roll or whatever. So this is the T-molding I went with originally. It's really great T-molding. It's very industrial. It's really hard to bend. very durable. But the one thing I didn't like about it was it had a very short tongue that goes in the T-slot. And I was a little worried about that, it not being long enough to hold. And so I wound up rethinking my T-molding, and I wound up getting different T-molding from a different company, and I'll put the link in the description, that had a much longer tongue. But the only problem was the tongue was way thinner than this T-molding. And this is the one I planned on using, and this is why I cut the T-molding, the T-slots, as wide as I did on this. So I wound up getting different T-molding, like I said, and I had a thinner tongue, and I wound up having to rethink my T-slots again. So this is like the second time I'm messing up the T-slots. More drama. So anyway, I wound up doing something that would help fix this whole situation. Here you could see a kind of cross-section of what the first T-molding I bought looks like. You can see it's got a really wide tongue, but it's not very deep. The second image you can see here is the second T-molding I bought with the thinner tongue, but longer tongue. And you can see the problem. Now, the slot I already have cut is way too wide. So what I wound up doing after much thought, at this point it was too late to start over. So what I wound up doing was coming up with this idea of just cutting a bunch of thin strips of pine with a table saw that are wide enough to just go in the slots. And then I would basically glue all of these pieces and fill the slots back up. I really didn't want to have to do this, but this is what I wound up doing, and it actually worked out. So I was able to just redo, basically just take a pattern bit like I've done before and just clean up all these kind of pieces that are, you know, sticking out, and reflushing everything up to basically fill in the hole. I mean, there's probably other ways to do this. You could probably use body filler and that kind of, you know, Bondo, try to go that route, but I didn't want to do that. I thought that would be way too messy, and I really don't like the smell of Bondo. So I thought this would be a good alternative. Just basically filling in the slots and then recutting the slots again after that with the 1/16 inch slot cutter. So that's what I did. So this is one of the wide slots that I cut on the control panel. These are some shots of the slot in the control panel being filled in with a wood strip. Nothing exciting here, but I just wanted to show you guys. This is me cutting some of the strips on my not great table saw. It's actually not great to do this kind of thing on this saw, but it worked well enough for this, what I needed to do. I mean, you're not going to see any of this. I just needed to fill the holes and be cut off. Here's some close-up shots of the Marquee bezel. How there's some saw marks in it and stuff like that. That would be filled eventually and smoothed out. Sound. So here we get to the sound portion of this video. So I bought these cheap speakers, I think from Five Below, because I thought maybe they would be usable. And this is what they sound like.
It stinks!
Yeah, not good. So as luck would have it, we were getting rid of an old stereo system we had. I was like, well, let me check out those speakers. So I went up, you know, opening them up, and it had perfectly good usable speakers for this arcade. They were the right size and everything, so I wound up doing that. Okay, so up to this point, I really didn't have a good plan for how I wanted to do the audio and the speakers and that kind of thing. I was just gonna do it like the guy from Geek Pub did his, where he just has speakers inside on the left and right sides of the arcade, and he just drills a bunch of holes and then just hot glues the speakers to where the holes are. And I thought I was going to do that for a while, and then I thought, you know, I think it would be really cool to have the speakers like on a real arcade where they're kind of mounted to the front underneath the marquee. So that's what I wanted to do. So this is now I have to kind of rework some of the design. We'll see what that affects coming up in this video. And so this is the amplifier I went with off of Amazon. And don't tell Jeff Bezos, but they actually sent me 2 of these for some reason. I mean, they're cheap. So I had like a backup one if I needed it. I'm not sure why I wound up with 2. So the other thing I wanted to do was, if I'm going to have this little amplifier, it would be nice to have access to the volume knobs and that kind of thing. And it looks really cool because it lights up and there's multicolor LEDs in it and stuff like that. So I figured I would feature it on the front of the arcade by cutting a rectangular hole and kind of mounting it there. The thing also, because the 3/4 inch MDF is pretty thick, I didn't really want to have the faceplate of the amplifier to be really deep in a hole. So I wound up having to modify the mount for the amplifier, and I'll show you that coming up, how I kind of solved this problem. And there's more 3D printing involved. So here's the front of the arcade, and these lines I kind of measured out, and this would represent the hole that I need to cut for the amplifier. Here I am modifying the mount for the amplifier. I just had to cut a little off so I could shove this into the hole that I cut. And this would bring the faceplate of the amplifier right up to the front so that it wouldn't be in this deep hole. And then I would make a 3D printed bezel to go around the whole thing and to make it look nice and cover up the edges. And a few broken bits later, I have a nice modified amp. Here's the amp. I stuck it in a vise because I wanted to square off these pieces that I cut off because there was kind of a curve there. So I think I used a file for that. Here's the 3D printed bezel that would basically fit around the amplifier face, and then it would also go into the hole in the front of the arcade and kind of marry everything together. And then I'll kind of show you in a little bit how that all worked out. Here's the 3D printed bezel, so you can see how it fits onto the front of the amplifier. More feature creep. I thought it'd be a good idea to have a couple more USB ports on the front of the arcade in case we want to plug, controllers in or whatever. So I got one of these things off of Amazon where basically an extender, USB extender, and it has a nice little cover that you can close up. So I thought that'd be cool to throw on the front of the arcade. So again, I had to re-drill out the back of the hole for this USB thing that I just stuck in there because I couldn't get the nut on enough. It only went on like a half a turn. So I wound up doing the same thing again where I make a template with MDF and I used a Forstner bit to make a guide hole, and then I clamped that to the piece and then just drilled it from the back just to kind of take away some of the material to make the hole more shallow so I can get it has like a big plastic nut that has to screw on to hold it from the back. Here's a shot trimming off the wooden strips that I glued into all the T-slots to allow me to redo the T-slots. This is the pattern bit in the router table, and it came out great. I mean, it's perfectly flush and gives a new kind of point to start over with a new T-slot. So here we are currently. There's a lot of parts at different stages of completion. Some are primered, some are half painted, some have the T-slots re-glued with wood, wood in them so I could fix them. Here's the 1/16 inch slot cutter that I'm now using to make the thinner T-slots. I am the warrior. These are a couple test slot cuts, trying to dial in the center, so the slot would be in the center of the 3/4 inch MDF. And it's a little trickier than you would think. I had a hard time kind of dialing this in, so I made a lot of kind of test cuts until I finally got it right. So this is an actual recut of the T-slot on the control panel, and it looks like it's nice and centered. It looks like it's going to work out for the rest of this because I have to now go and glue a bunch of pieces of thin strip wood into all the rest of the slots. Here I'm working on the control panel, and you could see how tall the joysticks are going to be, which I think is a good height thanks to putting that pocket into the bottom where the joystick attaches. It gives you a little extra height on the joystick. Here's some shots of transferring the buttons from the old panel that I made a long time ago to the new one. Or actually, I think at this point I'm just taking them off and getting them ready to be put onto the real control panel. Okay, so this was nerve-wracking. This is the first time I'm trying the carbon fiber vinyl and actually putting it on something. And so I figured I would start with the control panel because that was the part that was the most done at this point. So I sanded the top of it to get it nice and smooth. Apparently that's good for the vinyl. So here we go. I'm laying it out and just taping the back of it so it doesn't move around too much. Yeah, it actually went out pretty well. The only thing I would say is the adhesive is not that strong on this. It was a little bit stronger, but this is probably where having a really smooth as glass surface helps for it to adhere to. But you know, I can only get the control panel so smooth. So I think it worked overall, but I wound up taping the back of it a little bit just to give it a little bit of extra support. So here it is wrapped, and I folded the edges over on the back. Then I put the Lexan covering on it, and man, does this look really cool. It just looks amazing to me. Very nice and neat and clean. And I recommend putting plexiglass or something over top of the control panel. It'll protect it over time because your hands are moving around and it's going to make it dirty and that kind of thing, and it's going to wear out whatever artwork or paint you have on the top. So yeah, I recommend putting a plastic sheet on top of the control panel. I figured I might as well start putting the buttons in and see how that all looks. And these are actually, I could put them in and just leave them in at this point because this piece is fairly far along, so it's pretty much almost finished. You can see here I put the MDF pieces on the bottom of it to kind of keep it elevated off the table so that the wires wouldn't get damaged and that kind of thing, just to give it some space. And then these would be removed when I put it in the arcade for real. And here it is with all the buttons and the joysticks. And just really happy with how this came out. This really kind of inspired me to keep going on this project because this was taking quite a bit of time. I didn't have a lot of time per day to work on this because I have a full-time job and that kind of thing. So I would try to do this on the weekends or an hour or two at night. So this, just having this part done and it just looking really neat just kind of made me want to keep going. So this is the control panel all together. We've come full circle. So now we're using it again by just hooking it up to the TV to play some games. It's cool. Really happy with it. I think the only thing left on this part was just the T-molding that goes on the front edge of it. But really happy with how it looks like. So more 3D design. So this was a speaker grill I designed. I thought it looked pretty cool. I like the hexagon pattern. But I wound up not using it. I wound up just getting some speaker grill covers off of Amazon because I thought they would probably be a little bit more durable over time. You know, I was worried that this would break or whatever. So I wound up printing these out, but I didn't really use them. So it's finally time to cut that rectangular hole in the front of the arcade for the amplifier. Of course, I 3D modeled and printed another router guide. And this was a little tricky because, you know, these parts are already glued together and nailed. So I can't really take the front off, but I was able to fit the router where I needed to. So I wound up putting this template on the inside of the arcade and routering it from the outside. So this worked out really well. The only problem is when you use a router bit, the router bit is round and your guide has square edges, you know, square holes or whatever. So you can't really do that. So I had to clean it up with a saw. I have this Japanese pole saw that I got from Harbor Freight that I really like, and it's great for this kind of situation. So this worked out. I just basically cut the curves out on the inside of the cut. So this is what it looks like with the amplifier and the bezel installed. And it's not the best 3D print, but it's good enough. And there's a couple holes and stuff that I had to fill and then paint it and stuff like that. But it's good enough for this, so came out great in the end. So this is what the amplifier looks like from inside the arcade. There wasn't really anything to hold it up, so I wound up 3D modeling and 3D printing these little standoffs so I could secure it to the floor of the arcade. These worked out great. I mean, I could have just used a piece of wood, but it's just pretty quick to model something like this, and these don't take very long to print at all because they're fairly small, so I don't mind just going that route because it's just quick and easy to do for me. So that's what I did. But you know, you could do whatever you want on your arcade. If you want to use little blocks, that's perfectly cool. Finally getting around to gluing the wood strips into the slots. I kept putting this off. This actually wasn't as bad as I thought it was going to be because I was worried about all the curves and trying to lay in, you know, these strips into these curves. But I wound up just kind of cutting little small pieces for the curves and kind of tapering them a little bit. And it wasn't too bad. This went actually way faster than I thought it was going to. So once all the wood strips were inserted and glued and dried, I just wound up throwing the whole arcade up on the router table and just using the flush trim bit or the pattern bit to just knock all the excess off. And this went fairly quick and it was pretty easy to do. Could have used the handheld router too, but I don't know, just I like doing it this way because it's a little easier and a little safer, I guess. This is so satisfying to watch this. That little hiccup at the end of that was the edge of the arcade caught the edge of the table from the router table and kind of caught, so it made a little jerking motion there. This is when I decided to test using a hole saw to cut out some of the bigger holes, just to see if I was missing anything, to see how the quality of the hole would be and that kind of thing. And I don't know, I guess this saw I have is not that sharp or something, but it just came out kind of awful, and I think it burnt the MDF a little bit. So this is only a practice test just to see, if I would like using it or not. And I didn't really like using it. So I'd rather do the 3D printed templates and go with that. So that's what I did. So here's yet another 3D printed router guide. This one I made for the speaker holes that would go below the marquee. This was kind of an afterthought. Like I said before, I was going to do the speakers on the sides, but then I wound up wanting to do them up front. So I had to rework how I'm doing the marquee lights, because that's a problem, but we'll deal with that coming up. So anyway, I 3D printed these router guides, and these worked out great. Nice clean holes, and I was able to, because a lot of the arcade is permanently stuck together, I was able to fit the router inside the top and router from the top. Yeah, it just worked out great. Here's a nice close-up shot of the pattern bit or the flush cut bit that I'm using on a lot of this. It's got the bearing down the end of the bit. You can get them with the bearing at the other end of the bit as well, but I wound up using this one for most of this build. So I should mention too, I did again where the 4 holes that hold the guide to the piece, the 3D printed guide, also coincide with the holes for the speakers. So you only have to make one set of holes and then everything kind of uses those holes, which works out really nicely in this kind of situation. MDF dust. Routers really make a lot of dust. I should mention, just like a safety thing, when I do these router cuts and stuff, it makes a really large amount of dust. It's really fine dust. It's like MDF dust, which isn't great for you. So I use a respirator and of course safety glasses, and I always use hearing protection too, because that's just important. You don't want to lose your hearing. Because these tools are loud. A router's really loud, and a miter saw is really loud. So it's just smart to use any protection you can get. Okay, so here's the speakers kind of in their place and kind of temporarily installed. And because I just wanted to see how they're going to affect the lighting for the marquee. And this is me figuring out an alternative way, because now I can't use that LED light that I bought earlier and did the mounts for, because now it's too big and in the way. The speakers are in the way and they're going to make a shadow on the marquee, so that's what I'm trying to avoid. So I came up with an alternate way where I'm going to have a little board like this that's mounted, and it has LED strip light, which I previously bought, and that will spread the light out enough to minimize any kind of shadow that the speakers might cast onto the back of the marquee. So this is me just kind of moving this light board around and seeing where it needs to go. So that's what this image is. So this is the black spray paint I wound up going with for the black surfaces. It comes out really great. You just have to layer it up in thin layers and sand in between layers with just real fine sandpaper just to kind of smooth it out, and eventually you get a nice finish. And it's really durable too. You can put your fingernail on it, it doesn't really scratch, so I recommend this paint. So back outside, these are some of the parts, and I'm putting more layers of black paint on them, and I think they get better and better with each pass. So that's where we are now. So I dragged the arcade outside again, and it's kind of rough going up and down the Bilco steps there, Bilco door steps. But this thing, I mean, it's not that big, but it's fairly heavy, so it's a little unwieldy to carry it. But here I'm adding more black paint to the inside edges, because I'm not really going to put any kind of coating on that. no vinyl sheet on that. It's just straight paint. So that's what I'm focusing on here. So this was my first pass at the design for the Marquee, and I had it printed onto vinyl by a company I'll put in the description. They did a really awesome job. Unfortunately, my measurements were a little off, and this curved element was supposed to not be behind the bezel, and for some reason I totally messed that up. So I had to kind of rework the design to bring those curves in farther, and on the final one that's all fixed. And I didn't really dig the color so much on this one, so I tweaked the colors to get it to match the arcade a little bit better. But I'm really happy with the overall, the print quality, how that came out. And it was really affordable. I was really surprised. I thought it was going to be way more money. I think it was like, I don't know, 18 bucks or something. It was like really cheap. So anyway, this is where we are now. So here I found a scrap piece of MDF that I decided to use for the LED light board. It's like, it's fairly thin, it's like a 1/2 inch or whatever thick, and just big enough to fit in. And so here I'm laying the LED strip lighting on the board, just doing it in rows. And at the end of each row, I just kind of twist it and, back on itself so I can come back and do the next row. And that worked out really well. And it was sticky enough to stay on the MDF. Okay, that's done. Here's all the LEDs lit up. It's pretty bright, I have to say, and I think it's going to work great. Hey, that's me! My future is so bright I have to wear shades. So here's another quickie design. This is for a little bracket that will scrap piece that has the LED lights on it. Just something quick I drew up so I can have the dimensions, and then I would build it in 3D and then 3D print it. And here they are. I'm actually having fun designing and printing these brackets because, I don't know, they just look kind of cool. And I'm trying to make them, have a little personality to them, if that makes sense. So here I'm installing those brackets, and I just screwed a little piece of plywood to each one, and then that will give me kind of a base to stick the LED panel onto. And I'm trying to remember, I think I just wound up hot gluing it once these were screwed down, so I think that worked out well doing it that way. I wound up having to modify a couple of the spacer blocks for the marquee glass because now the speakers were in the way, so it needed like an arc cut out of them. And I wound up just doing it this way with the bandsaw instead of redesigning them and re-3D printing, so that this was like a 15-second fix on these couple pieces. Only 2 pieces need to have this done. I was a little bit worried about the speakers casting a shadow onto the marquee, but I did a couple of tests here, and I set this up and I put the marquee on, and I really didn't see any shadow whatsoever. I was really surprised by that. There's a lot of light coming from a bunch of different angles, and if there is a shadow there, it's probably really, really soft and really faint, but I didn't really notice any difference in it, so I was pretty happy about that. So this is the second version of the Marquee Artwork, and I was really happy that everything worked out. The curves are within view, they're not hidden behind the Marquee frame or bezel. So yeah, and I really like the colors. It's more red and blue, which kind of goes with the joysticks and the buttons, so that all ties together better. Yeah, really happy. And you could see this is now with the LED light strip lighting, and you don't see any shadows or anything from the speakers. So I think that all worked out really well. I'm really happy. It's my favorite part of the arcade so far. Here you can see the fictitious company name that I like to use. My name is Dan, and my last name starts with a D, so I came up with Dandy Co., which is kind of a funny name, so I kind of stuck it on here because I thought that would be funny. Here you could see the Marquee Artwork with the plexiglass layers, and this is with the bezel taken off, so you can actually see how it all works. You could see that the plexiglass or the Lexan is like totally flush with the inside of the parts, if that makes sense, and then the bezel just goes right on top of that and just secures everything. So the artwork and plexiglass is being held the right distance away by all those adjustable brackets that are inside. I really like the way this works and the way it came out. It's really coming along at this point, and it's almost vinyl time. time. So kind of getting ready for that, and probably procrastinating a little bit because I'm not really sure how it's going to go. So that's where we are now. Fairly soon I'm going to be doing vinyl. This is the screen panel, and I wanted to go with this kind of matte black vinyl that I found. So here's that matte black vinyl on the panel, on the screen panel, and this is before I got the courage to cut it out where the holes are, and it was a little nerve-wracking, but it came out great. You just have to take your time and use a really sharp knife. I used one of those razor knives that have the blades that you break off, and it came out great. Now I'm moving on to the carbon fiber vinyl, and this is the the piece where the speakers are. So I figured I would do that one next. Here you can see it's looking really cool. I'm really happy with this carbon fiber vinyl. So this is an attempt at doing the first side, which is a fairly large piece, and it didn't come out great at all. I wound up redoing this. I ran into some issues with wrinkles, and in my head I thought that you could heat this vinyl up to get it to kind of stretch a little bit or whatever, and it doesn't really work like that. You could see there's a mark there where I used a heat gun, but it wasn't real close, but it was enough to melt the pattern. The carbon fiber pattern in this vinyl is really just melted in. Yeah, this stuff does not stretch at all. I was kind of thinking it was like monocoat for RC airplanes. I don't know if you guys ever used that before or know what that is, but when you heat it up, it kind of shrinks and sticks and that kind of thing. And I thought in my head, if I heat this up, maybe it's a little bit more easy to work with. So don't do that. Don't do what I did. I mean, this piece was doomed from the start. I think I just had issues. So I because it was rolled up, and then you have that problem where it has that it wants to roll back up while you're using it. I had to kind of rethink how I was going to do this. So the second attempt was way better, went way smoother. So this was a dud, this pass. Yeah, so here's a close-up on the burn spot where it kind of melted. So here's where I just pulled off that catastrophe, and I'm starting fresh again with a new piece on that side. Yeah, so that side came out like perfect. So I went on to do the other side, and I did the front and whatever else I needed to do. I should note on the sides there, and wherever you can, if you're going to have T-molding cover the edges, it's smart to make your vinyl wrap around the edges a little bit, and that T-molding will help hold it in or hold it down and secure it. So that's what I did. You can see in this shot that the vinyl wraps around a little bit right up to the T-slot. So this is nerve-wracking too. Putting the T-slot in. I wanted to go all the way around and have it also on the bottom, because the way I was going to do a base eventually, the side panels will overhang, so you would actually see that. They wouldn't be covered up. So I wanted to go full all the way around. So I figured the best place to put the seam in the T-molding would be at the bottom where no one can see it. So that's what I did. So I started to lay this out, and I was really digging how this was all looking. Once you start putting the T-molding in, it just feels like a finished piece, and it looks like something you would buy in the store or something. So I was really, really happy with how this is coming out. I didn't use anything fancy either. I think I just used my hand just to bang it in to secure it into the inside curves and that kind of thing. It wasn't hard to put in, but it's sturdy enough. It's not going to pull out. So yeah, it's coming out great. So far, so good. Okay, now we're getting to the end where I have to deal with that seam. And that's pretty nerve-wracking. So I wanted to make sure that I didn't cut it too short. So I kept sneaking up on it and just shaving off a little bit and then trying it to see if it fit. And eventually I got it like pretty perfect, I think. So I'm really happy with how that came out. Here I put the trim on the control panel. Looking pretty sweet. So here's a shot of that amplifier bezel after I cleaned it up and painted it with that same black paint that I used before. I think it looks really cool. Came out really neat. Here I did the wiring for the fuse and power supply. Yeah, really look at the instructions for this. I think they have them. I bought this off of Amazon, and they had the instructions right on the page for the product. Yeah, just follow that close, because I guess you don't want to mess this up. This is what the back wound up looking like, which looks really nice, I think. It's nice and clean, and I think the paint came out really nice on this, even though this is that piece that had a bunch of like imperfections in it, but it's the back, so who cares? But I'm really happy with how it's coming out so far. So here's some still frames of the final assembly where I'm starting to put all the pieces together. And this was so exciting to see this all kind of coming together and actually becoming an arcade before your eyes. So it was pretty cool. So here it's pretty much almost done. I just put the Lexan clear plastic sheet on top of the screen panel. So that really kind of makes it all come together. It feels like an arcade. And happy I did that because I think it keeps a lot of dust away from the screen and that kind of thing, and it protects the screen. But yeah, really cool. And I got the emulation station up and running on it. So my official game tester gave his seal of approval. He came down and tried it out, and he really likes the Mario games. So that's the first thing he tried on this. Yeah, it's amazing. I'm so happy with how this turned out. I know I said that a million times already, but this is like one of those projects where just like everything kind of worked out and came out great. So I highly recommend doing one of these if you're going to build an arcade. It's a good project to develop some techniques on and try new things. There's a lot of stuff on this that I tried for the first time, like with the vinyl sheets and, you know, the car wrap and printing, getting things printed onto vinyl. T-molding, I've never really done before. You know, it's wiring-wise and that kind of thing, and software-wise, it's not too complicated, and everything's online. So you could just, you know, Google search whatever you don't know or need to figure out. Yeah, I'm really happy I did this project. I did it during the COVID break or whatever, so it was a good time to do something like this, and I lucked out in that I had a lot of stuff that I needed already to get started. So awesome. Thanks for watching this video, and I hope you learned something, and hope you go and try to build your own. Thanks a lot. Thanks for watching. Really appreciate it.